Good afternoon, morning, or evening, depending on what time it is there when you're watching this. So we're going to be looking at definite integration today. So it's integrals where we have numbers and what it represents and what it means for us in calculus. Okay, just like the derivative of something represented the slope of a curve, the definite integral of something is going to represent the area under that curve. So that's what we're going to look at today. So I'm just going to wait for the Blackboard to pop open and set up my preview here. Okay, slide this over. Okay, get this a little bigger over here. Okay, so what are we going to do today? So we're going to look at something called definite integration. This is day 6 of the last unit, integration. You may see that there's a topic 7 on there, but it's got no percentages on it, as somebody mentioned to me during track. And that means that that's an optional unit that we can get to if we get that far. And that's basically for people going on to university. It's really not part of the course curricula that we need to cover. So we're going to cover up to and including the integration part here, and that's what's going to be on the exam. If we get through our exam study, we might look at that just for people that I'll put it up online, but you won't have to worry about it more than likely, as that's, like I said, an optional part of the course. Okay, so let's start off with what we're actually going to do today, and it's called something called definite integrals. So what we're going to do with definite integrals is what do they mean in calculus? Okay, we're going to be looking at the fundamental theorem of calculus. And we're going to be looking at just some examples. We won't do any practice till tomorrow. I'll leave that for tomorrow. Okay, of how we're going to use this definite integral thing. So definite integrals are the result of using a definite integral gives us the area under any curve. So what a definite integral is, first of all, is what we'll put up first. So let's put our title. This is day 6. So day 6 will be this, day 7 will be practice, day 8 and 9 will be area under the curve between two curves rather than one curve. And then day 10 will be a practice, day 11 will be the hand-in, day 12 will be the outline, and then the exam. So you're looking at a week and a little bit of class left. This is the approximate day I'm suggesting this year is May 24th here. So we'll be done early June, which will be nice for all of us. Okay, I should put day 6 up here because I usually do. All right, so let's look at definite integrals. Let's start with a definition here. I guess we'll use the marker because you got to use just kind of what the equation is. So the definite integral if you are looking at it, okay, so let's set this marker up a little better here. Okay, if you take something and you integrate it from b to a. These are two numbers. Okay. And this is going to be equal to, we'll just call it capital F of x. So the integral, right? And this is basically a definite integral. So we don't, these are the upper and lower limit. Okay, so this is the limits of the integral. Okay, so if you're looking at it in terms of graphically, so if we put up a little diagram beside it, I guess I should put the limits in the f of x as well here. Traditionally, we use a square bracket in calculus to represent our limits. Okay, so we'll do like this. Some people don't use a square bracket, they just use a line. Okay, and then you'll put your limits on there, and in this case our limits, our upper limit is b and our lower limit is a. Okay, so you would just put them in the same spot so that you don't get confused between the two calculations. So b is our outer limit or our farthest limit, and a is our under limit. So if we're doing that, it looks like same way here. B here and a here. Okay, and this is our integral part. And I'll do an example and then it'll become a little better or a little more clear with us. And the way we like to do definite integrals is usually the constant term cancels out in these. So then we can actually find actual numbered values of what we're trying to figure out when we're doing definite integrals. Okay, so the first thing we're going to do is just a little diagram here of what we're talking about when we mean a definite integral. So what does this mean? So if we had a little graph of a curve, well, we better keep it above the, make it a little easier. Well, yeah, I guess I better. Let's just make it an easy one. Say that it hits right there. So if we're doing from B to A, so this would be A here. Say A is right here. And this is B right here. So what we want is we want this area here. So this represents area under the curve right? F of x, not the capital F of x because that's the integral. Okay, from limit a to b. Which a and b are just two x points of that would be in the graph. Okay, and it's also to the x-axis in this case. So it just stops right there because then it gets negative here. Later on, we're going to do area between two curves, and it'll be a little bit different because we'll have to combine equations and do things like that. But right now, we're going to do a simple example. Okay, so that's what a definite integral is. It's taking whatever curve you have, taking the integral of it. That's what this represents here. We should maybe label that. Oops. Switch pens here. So that's capital F of x is the actual integral of that equation. So let's use our example here. Let's do an example of y equals x squared. That's what we got drawn on the screen from 2 to 5. Okay, so let's do that example using this idea. Okay, so we'll do it right underneath here. Simple example. Okay, so what is the area? What's the area under the curve y equals x squared from 2 to 5? Okay, so let's get the squared figured out. Okay, so if I do a little sketch here. So this is our upper limit. Okay, because it's farthest to the right. So we're going to subtract the bigger area. So this goes from 0 to 5 when we do the integral, and this one goes from 0 to 2. So we're going to take 0 to 5 and subtract 0 to 2 to get the area in between the two. So that's why the upper limit starts way out to the right. Okay, so we go like this. We need the definite integral from 5 to 2 of x squared dx. Okay, now we have to use the integral rules for calculus. So this is going to get x cubed over 3 plus c. Okay, and we want to take the values from 5 to 2. Okay, so that's our definite integral. So what we do is we take f of 5. Okay, then this represents, let's call this f, capital F of x, because we took that integral. It's not this curve, but it's the area under the curve is represented by this function because it's the integral. So this kind of represents f, capital F of x right here. Okay, the area under the curve. So now we just plug our numbers. Now we go f of 5 minus f of 2. And this is f of x to the third over 3 plus a constant. And you'll see the constants cancel out once we do it here. Okay, so let's go ahead and do the algebra. Okay, f of 5, so that would be 5 cubed divided by 3 plus a c, right? Minus, okay, now you have to be extremely careful to make sure that you put everything in brackets so that you remember to put the leapfrog or distribute the minus to everything. And this would be 2 cubed over 3 plus a c. You can see the c's are going to cancel out, right? So this equals plus c minus plus c is going to cancel out. So we got 5 cubed over 3 minus 2 cubed over 3. So this is going to give us 5 times 5 times 5, which is 125. Oops. 125 over 3. And we got 2 times 2 times 2, which is 8 over 3. Okay. So what we do usually in calculus is we usually leave them as improper fractions when we're working them out. Okay. So in this case, we got 125 over 3 minus 8 over 3. Okay, use our fraction rules. So that's 117 over 3 square units. Sorry, guys. Or if you like to put it as a mixed fraction, I think this works out evenly, doesn't it? This goes 3 into 11, goes 3 times with 2 left over, 3 into 27, so this would be 39 units squared. And there's our area under the curve, 39 square units. Okay, so that's a pretty straightforward one. Okay, let's do one without a drawing. Okay, let's go with upper limit of 0, lower limit of -3 of 2x cubed minus x squared dx. Okay, there's nothing outside here with the dx, so we don't have to use substitution. Still just the power rule right now. So this would be, if we're doing the integral of it, f of x, we'll call it, equals, okay, the integral of this, okay, part here, if we're going to go use the integral rule, so 2x, okay, and then we go to the fourth, right? And then put the 4 underneath. Okay, we can do some reducing there, but we'll do it the long way here. And then we go with this one, negative, okay, x to the third over 3 plus a c. So we'll do a little reduce to get this to be x4 over 2 minus x3 over 3 plus a c. Okay, so there's our f of x, our integral part. Now we got to do the limit of this from 0 to -3, or the substitution, I guess, the definite integral we want. Okay, from 0 to 3, because 0 is our upper limit, -3 is our bottom limit. So what we do is we go, okay, that's going to be f of x, which is 0 minus f of -3. Okay, so if we think about 0 going into here, bang, bang, it's going to be just a constant. So, and the constants are going to cancel out. So often what people will do is they'll eliminate the constant and say that's going to cancel out because it's going to be minused in between. Okay, so you're going to end up getting all of this to 0 minus x to the fourth, so -3 to the fourth over 2 minus -3 to the third over 3. Okay, and that substitution with the 0 is just 0, right? Because the constant's going to cancel out. Then we just do some arithmetic in this case. So it's going to be negative. Okay, -3 times -3 times -3 times -3 is 81 over 2. And this one's going to be -3 times -3 times -3, which is -27 over 3. So that's going to be -9. So it's going to be minus -9. It's going to be plus 9. Okay, so if we want to kind of do this one, change 9 to halves, 81 over 2 plus 18 over 2. So this would end up giving us 81 and 18. If we add those two together, we get 99 over 2, negative still out front. Okay, so that'd be -99 over 2. Or if you like it as a mixed fraction, over 20. No, over 2. Pardon me there, guys. Just threw an extra 0 on there for no particular reason. So negative 99 over 2, that would be 49.5 negative. And that is another definite integral, okay? And we should always go units squared because it represents area under a curve, okay? Okay, it could get a little more complex than that. Let me just pop up my preview here to see where we are with those two examples. Okay, we're around 21 minutes. Okay, so let's do the next part that comes into play is what about examples that are going to be using the other kind of integration that we did. Okay, what if we had a situation where we had to do a substitution of a definite integral, where we have to use substitution value? Let's do one like that. Okay, so this would be an example here of a definite integral using substitution. Okay, so let's say this is where you plug in the u value, right? Okay, so let's say I had something like this. The integral from 4 to 2 of x square root, I don't need brackets here. I don't know why I'm putting brackets. Book wouldn't put brackets there. Let me do it this way. So that's better. X square root of 25 minus x squared dx. Okay, so we've got a situation there where there's an x dx in there. Okay, so this would mean that we have to use u is going to equal 25 minus x squared. So then we're going to represent that and get their du dx. Okay, this is nothing because it's a constant. And this is going to be minus 2x. So then if we represent that in du, this is going to become minus 2x dx. Okay, and we want, as we can see there, we want it changed into x dx. So if we divide this by negative 2, okay, if we divide by negative 2, this becomes x dx, right? If we divide that there. So now we can sub it into here, keeping our limits. The thing is here, you have to change your limit. The limits have changed. This is what catches a lot of students. This is a very important step, okay? The limit has changed. Okay, so you have changed it from x to u. So you want to change it to u. So change your limit. So I'll do it right here. So u equals 25 minus x squared. So your upper limit, it's really easy to change your limits, but students often forget. Okay, so we've got to put in an x there. X is 4. So our upper limit becomes 9, and our lower limit Okay, our lower limit 2, we got to plug in a 2. So there's our lower limit, there's our upper limit. Okay, upper limit has become a 9, lower limit has become a 21. So now, once we do that, I should probably write this out as steps. So step 1 is do our substitution. Step 2, did 1 substitution. 2, change limit. Okay, 3 is write out the equation in terms of u. Okay, so now we're going to, in terms of u. So this, then, if we're doing it carefully, we got to kind of put it all together here. So let's look back up here. So this is going to be, okay, we're going to have x dx is going to become du over minus 2, or negative 1/2 times du. So this is going to become changed limits of 9 to 21 of u and negative 1/2 du. Okay, or du over negative 2 is the same thing. Now we have to bring the negative 1/2 out in front of the integration sign because we just want u du underneath the sign. Rewrite the equation, okay, and then calculate, integrate. Okay, so that would be negative 1/2 from 9 to 21 of u du. Now we're ready to integrate here. Okay. Now we integrate here. Okay, so this would be, we'll keep it underneath here, negative 1/2 u squared over 2, okay, plus c. What am I doing here, guys? What am I doing here? Let's go back to one step. My substitution, I forgot to put the 1/2 on top. Let's erase this because I'm being stupid here. It was the root of that. It wasn't just that. So the root of that. Pardon me, guys. I should have had a 1/2 on top here. I forgot to put the u to the 1/2. See, I put it there and then I forgot about there. So this would have been u to the 1/2. There we go. That's better. Okay. So now we have to take the integral of it. Okay. And the 1/2 comes because of this. This is square root, right? This to the power of 1/2. Sorry about that, guys. Forgot to do that. Okay. Put that negative 1/2 there, but put that 1/2 because that represents u to the square root. Now we're okay. Now we can finish integrating. So this is 1/2. Okay, now when we integrate this, 1/2 plus 1 is 3/2. Okay, and then we have to divide by 3/2 as well, plus c. Okay, so we got to work that one out from 9 to 21. Okay, let's do a little bit of simplification when we're doing this. Okay, so we can take the negative 1/2 and the 3 over 2 and work those out. Okay, let me just get my thing lined up here. Okay, so now what we can do is we can simplify. Okay, so let's simplify this. Okay, negative 1/2. So this would be, you're dividing by this would be like multiplying by, this would be like negative 1/2 multiplying by the reciprocal of this times 2 over 3 u to the 3 over 2 power plus c. Okay, sometimes you'll see it written like that as well, rather than square bracket, but I put a little square bracket in there. Okay, and this would be negative 2 over 6, which we can reduce to 1/3. Let's do that right away. Okay, because the 2's cancel out. Negative 1/3 u to 3 over 2 plus c. All right, now we just sub in the values of the limits. That c is going to cancel out. So we're going to go f of 9 minus f of 21. Okay, so this is 6. This is sub the number in, or the limits numbers. Okay, so here we are. We're going to plug it in. So we go, in our case, it's negative 1/3 times 9 to the power of 3 over 2. Okay, we're going to put decimals in there if you want. Minus negative 1/3 times 21 to the power of 'kay. So in this case, we're going to have to do some rounding unless we can, unless you know your exponents really, really well. Okay, which we can do. So this would be, if you're doing this one, negative 1/3. Okay, 9 to the power of 1/2 at 1.5 is actually 27. So that's nice. And this is negative 1/3. Okay, 21 to the power of 1.5. Whoops, did it wrong there. Gives us a decimal number. So we're just going to round it off. 96.2. Okay, so now we have to work it out. A negative 3 times 27, that's 27 divided by 3, that would be negative 9. 90, I'm just going to keep that on my calculator and divide by the negative 3. That's 32.1. I get 0.7, so I'm going to go sorry guys, and we have to add these two. So negative 9 plus that gives us a 23.1 square units. So there's an example of using substitution with definite integration as well. Okay, let's take a look at our time here. Okay, that's 33 minutes. Okay, I'm going to leave the practice for tomorrow. So maybe I'll squeeze in another quick example here, and then we'll do the practice tomorrow, even though I'm pushing it here a little bit. Okay, let's do one more substitution example. Let's say we had 0 to 2 of 9 minus x to the power of 1/2 dx. All right, so let's work it through. So first thing is, let's do the sub. U is going to equal 9 minus x du dx equals, okay, 0, negative 1. So du equals negative 1 dx. Okay, so that's pretty good. Nice little substitution. Okay, we have to change our limit. Next, so we're going to be doing this. So upper limit first, we put a 0 in. Okay, and lower limit, 9 minus 2 equals 7. Okay, now after we've got our limits in, we rewrite the equation in terms of u. So 9 to 7. Okay, this is going to be u to the 1/2. Let's not screw it up this time. Negative 1 dx. Okay, so we can bring the negative 1 out. That's a 9. Okay, and then we have d u left alone. So now we can do the integral of that. So we know that this is going to be, if we do the integration, let's move this so we can see. If we do the integration now, we take the integration of u to the 1/2. So we're going to be adding to get it 3/2. So this will be negative, because this negative is going to come in there, u to the 3/2 over 3/2 plus c. Okay, so if we want to use multiplication because it's easier on us, we can convert that to say that f of x, capital F of x equals, flip this over, negative 2u to the 3/2 over 3 plus a c. Okay, just flipping that over when we're dividing it. Okay, and then we got to do our limits here. I forgot to put 9 and 7 in here. Okay, and now we just plug them in. So negative 2 times 9. You notice that we don't go back to x with this. And the reason we don't do that is simply because we've converted them. We changed our limits with the u. So we changed the variable and we changed the limits. So we don't have to go back. You could not bother changing the limits and then go back, and then that works as well. But this is probably the easier way to do it. So this is 3/2 over 3. Okay, minus negative 2 times 7 to the 3/2 over 3. Sorry about that square bracket there I was using. That's a round bracket. Okay, so if we do that, variables, first one becomes negative 18, and the second one becomes positive 12.3. If we use our calculator, so this is going to equal negative 5.7 units squared. Okay, so that's what we're going to do today. So next day, I'm going to actually put the practice up. So day, 7, you can just do the practice. So that's the instructional part. So we'll stop the video here. That's a good 40 minutes almost. So that'll be way too long if we went into practice. So tomorrow you can do the practice sheet, and then we'll get into area between two curves next day. Might take us 2 days, and then do that practice, do the hand-in, talk about the exam. Poof, we're done the course, and then it's the final exam. I am going to allow a cheat sheet, so you can start making it now. One 8.5 by 11 sheet where you can write down any formulas or anything you want on there for your final exam. You have to make it. I'm not going to provide a final exam sheet of formulas. You have to have it on there yourself. Okay, I will go through that with you when I study for the final exam in June, with what you could expect for questions and stuff. Okay, types of things that you're going to see, so that'll help you build that. Okay, good luck. We'll see you tomorrow.